Okay, welcome back, guys. I'm going to be dealing on a question on that Graham's law of diffusion. Now, let's take a look at this question. The rate of effusion of hydrogen is 5 times that of chlorine. What is the density of chlorine? Now, remember I told you when I was taking the laws of, or the law of Graham, what Graham stated, I told you that in calculation you can see either effusion or diffusion. So don't get confused when you see effusion. It changes nothing. Alright, so now let's say the rate of effusion of hydrogen is 5.9 times that of chlorine. What is the density of chlorine? Now remember that I said the rate of diffusion of a gas is inversely proportional. I said the rate of diffusion of gas is inversely proportional to the square root of its density. Now we have here that R, let's make here an equation. R will be equal to K over root of density. So we have is to be that R1 over R2 will be equal to root D2 over D1. Now this is a formula for Graham's law on that rate. Now I told you that density is equal to mass over volume. Now 1 liter of a gas, or 1 dm cube, our density will be equal to mass over 1. So we have density is equal to mass. So we can place in the density as mass here. So we have it to be that the rate R1 over R2 will be equal to root M2 over M1. Now as we go, you see the difference between where I brought out this formula instead of this. Okay. So now remember I said our R1 to be hydrogen, then our 2 here will be that of chlorine. So now remember our relation was ROH is equal to 5.9 ROCl. So now let's look at the rates. We have R1 to be 5.9 ROCl over ROCl, which is R2 is same thing as ROCl, which is the rate of effusion of chlorine. So now is equal to root. Now they say what is the density of chlorine? Now if they are asking for the density of chlorine, which is M2 there, we will assume that our mass or the molar mass of chlorine is unknown. Since they are asking for the rate of the density of chlorine, we are assuming our mass, which is M2 of chlorine, is unknown. So let's make our M2 unknown over M1, which is mass, which is for hydrogen. For hydrogen, we have it to be the atomic mass of hydrogen is 1. So for 1 mole of hydrogen is times 2, which is we have H2 here. So times 2, we have it to be 2 gram per mole. So we have here to be 2. So now let's cancel that. We have ROCl, we'll cancel ROCl here. We are left with 5.9 is equal to root M2 over 2. So now what do we do next? We have to square both sides. Square both sides. So this square will cancel the square root. Then we'll square 5.9. So squaring 5.9 here, we should have it to be 34.9 H1 will be equal to M2 over 2. So now let's cross multiply. We have M2 will be equal to 24.81 times 2. We have it to be 69.62, which is approximately 70 grams per mole. Now this is the mass of chlorine. So obviously you should know that chlorine has an atomic mass of 35.5, but for 1 mole of chlorine molecule, Cl2, it should be 35.5 times 2, which is 70 grams per mole, which also we have here 70 grams per mole. So obviously calculations we are having here should be correct. Now in chemistry, in any calculation you are basing on, any calculation you are doing, your answers that is to be given should be related to what it's supposed to be. Let's assume we're asked to find the mass of nitrogen here. Then you are having something like 17. It should be 17 grams per mole. It should be incorrect because the mass of nitrogen is supposed to be 28 grams per mole. So any calculation you are doing should be approximately that of what it's supposed to be. So now we have this mass to be 70 grams per mole, which is the same thing as what we have here. Then for hydrogen to be 2 grams per mole. So now we're asked to find the density of chlorine. Now what is density? Density is equal to mass over volume. Mass over volume. Now the density, you have the mass to be 70. The volume was not given in the question, so obviously the gas is supposed to be at STP, which is at standard temperature and pressure. So now at STP, our molar volume of gas is 22.4 dm³. So we're dividing it by 22.4 dm³. So what should our density be? Our density should be 3.125 gram per liter. So now this should be the answer to this question, though it is long, but it's very easy to understand. So if you don't get anything, you can restart the video and watch again. You will surely get to where you were lost. So thank you. All right, let's take a look at this question under Graham's law. It says calculate the density of a gas at STP in a given volume of the gas effused through an apparatus in 6.60 minutes, and the same volume of nitrogen at the same temperature and pressure effused through the apparatus in 8.5 minutes. Now they said the volume are equal. So now remember I gave you a formula on our video when talking about Graham's law diffusion, that V1C2 over V2C1 is equal to root M2 over M1. Now you should recall this formula always as regard your questions that it depends on. Now this is our V1, our V2, our T1, our T2. Now let's take a look, or let's read this question out again. Calculate the density of a gas at STP in a given volume. Now the volume is known here. In a given volume of the gas effused through an apparatus in this particular minute, meaning the first gas was effused at this particular minute, and the same volume, meaning the volume of this gas, which is known but it is not stated, is the same as the same gas of nitrogen. Now because they say at the same volume of nitrogen at the same temperature and pressure, now effused through the apparatus. Now what are we looking for? The density of the unknown gas. Now our volume is equal, so we have V1, you can say V1 times T2 over V1 times T1. Since they are equal, so this can cancel this out. Now our T2 was given to be, this is the first term, 6.60 minutes. Then this is the other term, 8.5 minutes. So we have it to be 8.5 minutes. Now we can convert to seconds. Although converting to seconds does not really matter right here, because if you convert to seconds, you can cancel out the same thing, which does not change anything. But let's convert to seconds. So we have 8.5 times 60 to seconds. Then we have here 6.60 times 60, which is already in seconds, will be equal to root. Our M2 is known, which is for nitrogen. And what is nitrogen? Nitrogen is 14, but we have it to be N2 times 2. We have it to be 28. So we have 28 over M1. So now 60 will cancel 60, which is exactly what I said. So converting to seconds here does not really matter, because we are dividing all the same thing here. So let's divide 8.5 by 6.6. So we have it to be 1.288 approximately, will be equal to root 28 over M1. So let's square both sides to remove the square root that we have here. So this square will cancel the square roots. So if we square this one, we have here to be 1.66 approximately, will be equal to 28 over M1. So now let's continue from here. Then let's go multiply. The M1 will be equal to 28 divided by 1.66, which will give us approximately 16.9 gram per mole. Now this is the mass of the gas, 16.9, which is approximately 17, but let's leave it at 16.9. So now they say to calculate the density of the gas, not the mass of the gas. So now you remember density is equal to mass over volume. Okay, so now we have the density will be equal to 16.9 divided by molar volume of a gas at STP is 22.4 dm cube. So we have it to be 0.754 gram per liters. Alright, this is the end of this topic, or the calculation for Graham's law. So now I'm going to be dealing on the next subheading, which is partial pressure, and then we're moving straight to our new topic. Alright, don't forget, subscribe to our channel if you haven't, and then like and drop your comments. We are exquisite. We love you all. Thank you.